inequalities and identifying the overlapping solution area. Okay, so basically we're taking everything we learned and applying into graphing two inequalities at once. So let's see what that looks like. So here's our first example. So just like before, here's a little table, reference table. So if it's greater than or less than sign without the equal sign at the bottom, we're going to use a dashed line because points on that line are not part of our solution. If it has the equal sign at the bottom of the inequality sign, then we use a solid line because points on the line are part of our solution. So these two inequalities are in a format that we like because we can easily identify the slope and the y-intercept. So let me call that inequality 1 and this one inequality 2. So let me bring inequality 1 here. Y is greater than 4x minus 3. So automatically we know this guy here is our slope. The change in y is going to be 4 and the change in x is going to be 1. So up and down when we count, we're going to go 4 units. And then left and right, we're going to go 1. 3 is our y-intercept. So let's go straight, so not 3, negative 3. So let's go to negative 3. We have a line which has a slope of 4 and the slope is positive. So we know it's going to go up from left to right. So let's count 4. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right, and let's see if we can go 1 on the other side. 1, 2, 3, 4, 1 to the left there. We're going to use, and look, it's a greater than sign without the equal sign, so we got to use a dashed line. So let me use a dashed line, and there it is. What do we do next? Next, we take a test point. Pick a point on the left side of the line or right side of the line, and the best point to select is 0, 0, because that's the easiest one to substitute and evaluate. So we get y greater than 4x minus 3. We're going to replace it with our test point, 0, 0, see if it works. So 0 is greater than 4 times 0 minus 3. So I replace the x and the y with 0. So we get 0 is greater than negative 3. Is that true? Yes, it is. 0 is greater than negative 3. So that inequality true, which means that because this 0, 0 works, it also means that points on the left side of that line will also work. So let's represent that every single point on this side, on the left side of our line, is part of our solution. Okay. All right. So the neater you are, the easier you're going to be able to identify our solution. So that's inequality 1. Let's do inequality 2. So inequality 2 again is in the format that we love. Y equals negative 2x minus 3 plus 3. Plus 3, so we have a y-intercept right here. Our slope is negative 2, so let me just write that. Our slope is negative 2 over 1. So up and down, we're going to count 2 units, and left and right, we're going to count 1. So our slope is negative, so we know we have a line that's going to look like that. So 1, 2, and 1 to the right. 1, 2 down, 1 to the right. 2 down, 1 to the right. And so forth. Our inequality sign is greater than or equal to, so we're going to use a solid line because points on that line are part of our solution. So let's just go like this. And now we have to, just like we did with the previous inequality, let's use 0, 0 because it's available. So we're going to take the point 0, 0, replace x and y with 0, 0, and see if that inequality remains true. So we get 0 greater than negative 2 times 0 plus 3. 0 is greater or equal to positive 3. It's not true. 0 is not greater or equal to 3. So this 0, 0 failed, which means points that are on the left side of the line will also fail. So we don't want that side. We actually want this side. So points to the right or above the line will make the second inequality true. But notice that as I get closer here, that these two colors are going to overlap. So we have a region here where we have the blue and the purple overlapping. So that means that this whole area are points, resides points that satisfy inequality 1 and equality 2. So where the two colors overlap, that's the area, that's the solution for both inequalities. And we got to prove that. And to prove that, we're going to, let me just make some room over here. We're going to select a point here. Let's pick an easy point. Let's pick this point right here. 0, 6. 0, 6 is in this area that overlaps, that both colors overlap, right? And we're going to try it. We're going to plug it in inequality 1 and inequality 2, see if both of them remain true. So inequality 1, y is greater than 4x minus 3. So let's replace y with 6 and x with 0. So we get 0 greater than negative 3, which is true. So 0, 6 made first inequality true. So let's see if 0, 6 also makes inequality 2 true. So equality true is y. Let me change the colors here. Y greater than or equal to negative 2x plus 3. So let's replace the y with 6 and the x with 0. So we get 6 greater than negative 2 times 0 plus 3. 6 is greater than negative 2 times 0 is 0, and 0 plus 3 is 3. Is 6 greater or equal to 3? Also true. So, and if you like, on your own, you can select more points that are in this area, where those two, the overlapping regions from both inequalities, and you'll see that points on this area satisfy both inequalities. Okay?